In this video we explain a very interesting way to choose the right formula in kinematics. Please subscribe us. So far we have explored the concepts of acceleration. From here, we describe computational problems. Constant acceleration equations of motion, on a straight line. The following equations are very important in general physics. It can be said that it is the most important formula in kinematics, that is used in other parts of physics. It can be said that the rest of the formulas are derived from these 5 formulas. Some interesting tips from this collection. 1. This set consists of 5 equations and 5 variables. This shows that this set is complete. 2. If we combine 2 formulas from this set, we will get another formula that is in this set. 3. There are 5 variables in this table. But only 4 of them are needed to solve a problems. 4. In each problem, there are only 4 variables, 3 of which are known, and we must find the 4th. There are many people like students, who memorized formulas, but could not use them. We will tell you an interesting method.
Pay special attention to this note. If the velocity of a moving object is constant, its acceleration is 0, so we have only one formula. In this case, we do not use the 5 formulas. The 5 formulas are used when a moving object moves in a straight line at a constant acceleration. First of all, it is necessary to pay attention to the following concepts. Suppose an object moves in a certain direction. At moment the stopwatch starts, the location of the moving object is called the initial location. And the velocity that the car has at this moment is called the initial velocity. At moment we stop the stopwatch, the location of the moving object is called the final location. At this point the velocity of the object is called the final velocity. T is the displacement time, that is, the number indicated by the stopwatch. Displacement vector is a vector whose beginning is the primary location and whose end is the secondary location of the object. Acceleration is also a quantity that indicates the rate of change of velocity per unit time. Note that different sources for primary quantities use different symbols. For example, 0, initial, start is used for primary quantity. They all mean the same thing. The rest of the quantities such as position, velocity, and so on are the same. Similarly, F is used for the final quantity. The meaning is final. Or the symbol is used without index.
Now we examine the equations. In the first equation, there is initial velocity, final velocity, acceleration, time. But there is no movement. In the second equation, there is initial velocity, final velocity, acceleration, displacement. But there is no time. In the third equation, there is initial velocity, final velocity, time, displacement. There is no acceleration. The fourth equation, there is initial velocity, acceleration, time, displacement. There is no final velocity. Equation 5. There is final velocity, acceleration, time, displacement. There is no initial velocity. So each equation has 4 variables, and does not have the 5th variable.
A car moves at a constant acceleration of 4 meters per square second, at initial velocity of 2 meters per second, it moves for 3 seconds. How many meters can the car move during this period? Answer. The acceleration of car is equal to 4 meters per square second. The initial velocity of car is equal to 2 meters. Time is 3 seconds. So far 3 variables have been identified, and the fourth quantity is the displacement, that we must calculate. So 4 quantities are identified. Now we have to find the right formula. If you are careful, the final velocity variable is not required, then the appropriate formula is this.
Example, a moving object initially moves at a velocity of 4 meters per second, after moving 5 meters, his velocity reaches 6 meters per second. How many meters per square second is the acceleration? Answer, the initial velocity is 4 meters per second, the displacement is 5 meters. Its final velocity is 6 meters per second. So far 3 variables have been identified, and the fourth is the acceleration that we have to calculate. So 4 quantities are identified. Now we have to find the right formula. If you are careful, the time variable is not needed, then this is the appropriate formula.